Good evening and welcome to this calculus short where I'm going to go over this interesting question I found from a previous New Zealand Maths Olympiad. And the question says to find all real solutions to the equation such that x squared plus 3x plus 1 to the power of x squared minus x minus 6 equals to 1. So you can pause the video right now to see if you want to give a go to the problem yourself. Alright, so at first this problem might seem a bit daunting, a bit tricky, but if we just remember our simple power rules, we should be able to solve this question pretty simply. If we say that, so let's say that, for example, we can say that let y be equal to x squared plus 3x plus 1, and we can say z equals to x squared minus x minus 6. And if we remember from our power rules, we know that any number to the power of 0 equals to 1, except for 0. 0 to the power of 0 is not defined. But any other number to the power of 0 is equal to 1. So therefore, we can say that if x squared, not x squared, if z, which is our power, is equal to 0, so if z equals 0 and y is not equal to 0, because we can't have 0 to the power of 0, that's not defined, and y is not equal to 0, then therefore our equation will be satisfied. So we can just solve for x squared minus x minus 6 equals to 0. If we factorize this, we'll get x minus 3 and x plus 2. That equals to 0. So therefore we have our solutions x equals to 3 and x equals to negative 2. Now, if we want to verify that if these solutions are correct, we should plug in x equals to 3 and x equals to negative 2 into our equation for y to verify that it does not give y equals 0. So if we say y equals to y of 3, if we plug in 3 to our equation, we'll see should give us that equals to 19, which is not 0. So 3 is a solution. And if we look at y of negative 2, if we plug that into our equation, we should have 4. That should give us a negative 1. That's also not 0, so therefore x equals to negative 2 is also a valid solution. Now looking at our second case, we know that 1 to the power of anything equals to 1. So for example, 1 to the power of 6 equals to 1, 1 to the power of negative 4, that equals to 1. So 1 to the power of anything equals to 1. So therefore if I'll put our second one in a different color, we'll say blue. So if we say that, if we say y equals to 1, and z can be any number, so z is any real number, so we just say xer, any real number, then our solution will be satisfied, so our equation is satisfied, okay? So therefore we can just make x squared plus 3x plus 1 equals to 1. Sorry, my writing's a bit messy, but you should get the point. So x squared plus 3x equals to 0. And therefore x, if we factor out the x, we'll have x times x plus 3 equals to 0. And we should have the solutions x equals to 0 and x equals to negative 3. We don't have to test anything for this particular solution because 1 to the power of anything equals to 1. It doesn't matter what our z is equal to. Z can be any real number. So x equals 0 and x equals to negative 3 are valid solutions. There's one last case that we should consider. And that one last case is if y equals to negative 1. If y equals to negative 1 and the power is even, so if z is even, then our solution will be satisfied because negative 1 to an even power and negative times a negative is a positive, and we know that 1 to the power of anything still is 1. So therefore, if our y equals to negative 1 and our z is even, those solutions will be valid. So if we're going to solve for y equals to negative 1, we can say that x squared plus 3x plus 1 equals to negative 1. Therefore, x squared plus 3x plus 2 equals to 0. If we factor this out, we'll get x plus 2 and x plus 1. So therefore, x equals to negative 2 and x equals to negative 1 satisfies this equation. And now we need to test that if z is even, okay? If z is odd, then our solution is not satisfied because our result is negative 1, not positive 1. So we want to check if z is even. So if we just say, if we put in z of negative 1, if we plug negative 1 into our equation of z, which is, once again, is this guy here. So x squared minus x minus 6, so we plug out numbers in negative 1. 1. So z of negative 1 should give us negative 4. So 4 is actually considered an even number, so this is a valid solution. That is a valid solution. And if we look at z of negative 2, that should give us so negative 2 gives us 4 minus 2 minus 6 equals 0. So that's also fine because that's also even number. So x equals to negative 2 is also a solution. So therefore, we can write our total solutions. We have x equals to 3, x equals to negative 2. We have x equals to 0, and x equals to negative 3, and x equals to negative 1, because negative 2 is a repeating solution. So we have x equals negative 2 here, we have x equals negative 2 here. So we have 5 solutions to this equation, 5 real solutions, x equals to 3, x equals negative 2, 0, negative 3, and negative 1. So I hope you enjoyed that little problem, okay? It looks really tricky on the outside, but if you just know your simple power rules, okay, so just recall our simple power rules, you should be able to solve this problem. So I hope you enjoyed watching this video, and I hope to see you all in the next one. Thank you, bye.